Well, good morning, everybody. I hope it's a good day where you are. Here in Southeast Michigan, where I live and where I'm recording from, we seem to have a bit of a storm coming through. So hopefully you don't hear any of the thunder in the background. It seems like we're going to get about 1.5 inches of rain, which is pretty atypical for the middle of July. Typically, we're pretty droughty, and for whatever reason, we've had a pretty wet summer so far. Anyway, what I am interested in doing with you all today is recreating a data visualization that I found in the Washington Post last month that came out at about the time when there were protests going on in Los Angeles around the whole issue of immigration and Trump's policies regarding immigration policy and whatnot. Hey, Mike, welcome. Hey, Benjamin, great. Thanks for joining in. It's good to see those comments so I know that I'm actually talking to somebody and I'm not just talking to myself. Anyway, like I said, we're going to make a visual that you can see here from the Washington Post. And let me get my Windows set up here. I'm still trying to learn how to use this software, so I appreciate your all's patience. And that comes to us from... let me pull up the site here. I thought I had it. All right. So that comes to us from the Washington Post. This archive.is is a great tool for getting us access to what? to articles that are normally that are normally behind a paywall, right? And so I'm going to try to copy and paste this into the chat, but it's not letting me. So hopefully you can see it up here in the upper left corner. And this, when it comes to us from archive.is, the page looks a little bit janky. I think you'll agree. And so again, this was the results of a survey that the Washington Post did, where they texted people a variety of questions about the LA protests. I think they actually surveyed 1,015 people, and they kind of did a rundown in this article of what they talked about, right? And what the responses were. And so this is the visual that we're going to be taking on today, which is, do you support or oppose Trump sending the National Guard and the Marines to respond to the LA protests? So just for people to know, who live outside of the U.S., or maybe even people within the U.S., that domestic police presence in the U.S. is not handled by the military, right? That's kind of one of the founding things that set off the United States, that the British troops were policing the colonialists, right? And so it's a big deal when the National Guard or the Marines come out as a police presence in American cities. Normally that is handled by local municipalities. And so that was very weird, right? And it was unsettling. And so they have a variety of different types of data visualizations in here. And would encourage you to kind of read through the article. And like I said, the plot that we're going to make is this first plot. And I saw this and I thought that was, I mean, regardless of the data or the question or whatever, I thought it was an interesting plot, right? It reminded me a lot of a waffle plot, where in a waffle plot, you can imagine having a rectangle, right? And that looks like a waffle, right? And then each cell of that rectangle or each cell of that waffle would represent a different proportion, right? And so in this case, they have a different circle or blob indicating a different participant in the survey. And so they have all 1,015 participants represented by a different circle. And instead of like a typical waffle plot would put these three categories together into one rectangle, they split it out into three separate rectangles, okay? And so I thought that was interesting, right? And it got me thinking about, like, how would we do that, right? Another thing I thought was interesting about this was that they have a title with a border around it. And it's got rounded corners on 3 of the 4 sides. Honestly, I'll just tell you right now, I'll give you the spoiler. I don't know how to make 3 of the 4 corners rounded and 1 square. So I think we can go ahead and make a rounded label for the title. And then something that we talked about, I think in the very first live stream I did maybe a month ago, is that they have a Washington Post logo in the left-hand margin of this figure, okay? And so this is the plot that we are going to make today. There may be a ggplot related package out there for making these types of plots. I'm not going to use one of those. I'm going to use pretty much base ggplot to do the hardcore parts of what's in here. When I look at this, seeing these 3 different sections, I instantly think of the function facet wrap, where we could make each of these categories of support, unsure, oppose, a different facet, a different panel within the overall plot. Then that support, unsure, oppose with the percentage under them could be the label or the title for each of those different facets. Okay, and so this is what we're going to take on today in our studio. I have here a starter R script that I'm calling lawaffleplot.r. I'll have it here. Also, if you're watching this after the live stream, I'll go ahead and put a link to all of the code that I'm developing down below. I haven't done a lot of writing comments because I can't do that, but let's go ahead and, I can't think and write at the same time. I'll go ahead and, it's not, maybe if I paste like that. No, I guess I was going to try to comment the whole, or put the whole chunk of code in the comments, but I don't know. Maybe I'll give you the tribble itself and see if I can paste that in, and that lets me do that. So if you want to play with the data, it's there in the comments if you want to copy that and follow along. And again, here is the top part of this, doing this a bit out of order. Sorry about that. And that's kind of the head of it. And I'm sure the formatting on this is going to get pretty funky. And now that I know how to copy and paste, let me go ahead and try to copy and paste the archive link as well. There we go. So that's the link to this article, or free version of it at least, if you want to follow along or kind of dig into that article a little bit as I'm talking through things here. Okay. And good. All right. So welcome everybody. I see that we've got Mike in the UK, Benjamin in France, DIY Indo from Indonesia, Said Jama from Somalia, Lionel from the Dominican Republic. Dominican Republic. That is awesome to see people from around the world engaging and participating in this live stream. As we go along, if you all have any questions, please don't hesitate to put them in the chat over here, and I'll do my best to keep track of things. I find that this engagement is really wonderful for getting feedback, right? And for you all asking questions to say, hey, why don't you try it this way? Or what's your thought process? Can you explain this a little bit more? That's the beauty of being able to do this live. So I really encourage you to check that out. One other thing I would encourage you to think about is that I have a newsletter, right? And so if you go to riffomonas.org, you'll see that you can join the mailing list down here. I'll go ahead and plop that here in the chat as well. And as part of this website, like I said, there's a mailing list that will tell you about things that are coming up. And if you, actually, I don't know that I have a link off the main page, which is weird. So if you go to shop.riffomonas.org/posts, it's kind of going crazy here, posting links. So go there, you'll see the archive of all of the past newsletters where I effectively am talking about the visualizations that I'm going to be making in an upcoming live stream, right? So here is a waffle chart that I made a month ago, or 3 months ago, talking about Elon Musk's efforts to shrink the size of the US budget. And so that's where we've kind of got a little bit of waffle plots on the brain. And so then here is an article talking about the visualization for today. And so again, if you want to kind of get my 30,000 foot view of these plots, subscribe to the newsletter, right? And there'll be other things in there that you'll find, like information about upcoming workshops or other materials that I have available for you to use. There's also another data visual in here in this article that I talk about a little bit. I don't know that we're going to get to that today. Actually, we're not going to get to that today. I might think about that next time. So anyway, encourage you to check that out if you aren't already subscribed. All right. So again, thanks everyone for joining in. It's great to have you all. I'm going to go ahead and load stuff. I've got 2 packages right off the bat, tidyverse and showtext. I like using tidyverse because it gets me all these packages like dplyr, ggplot2, per, readr, stringr, tibble, just a lot of good functionality for working in the tidyverse, right? Showtext then allows us to bring in fonts from our system as well as from Google Fonts. And so a lot of the media outlets like the Washington Post, New York Times, your local newspaper, right, have perhaps proprietary versions of fonts or fonts that you'll have to pay extra for. And so Google Fonts does a pretty good job of providing free fonts that are approximations of what these news outlets are using, right? And so we will use Libre Franklin for the sans serif font and Playfair Display for the serif font in that title, okay? And so these are the functions, font add Google, where we give the name of the font and then the font family that we're going to refer to that as in our plot, as well as that Playfair Display. We then set the resolution with show text ops and then show text auto, okay? Great. Wonderful. And we've got Renzo from Peru. Wonderful. Is there anyone from the US? Maybe I'm the only one. This is awesome. Thank you. All right. And so then I went about calculating or counting the number of cells in each of the support, unsure, and oppose categories, okay? And so this is the math where there were 23 rows and there's 18 columns, right? So there's 18 columns from left to right in each of these 3 categories. And then there's some extras at the bottom, right? So there's 7 extra individuals down here under support. There's 5 under unsure, and I think 13 under oppose, okay? And so this then gives us our category and the level, right? The level of responses, right? Maybe we could perhaps we'll just leave that at level. But we have 421 support, 149 unsure, and then oppose is 445. So I could pipe this to say summarize total equals sum on level. Yeah, there's 1,015 responses to their survey, okay? Cool. And so we will use those numbers to create the cells in the 3 waffles, as well as to calculate the percent support, right? Because under each of the 3 titles, we have that percentage, right? The 41, the 15, and the 44. Okay, so we want to think about how we would plot this, right? And so right off the bat, I know that I need to make each of the 3 waffles. And so I want to make a function that will allow me to give an n value, as well as perhaps a number of columns, although by default it's going to be 18 to match this one. But so if I said that we have, what did we have? 421, that if I say that n is 421, the number of columns is 18, that then I want to get the coordinates for each of the points in this waffle, right? And then if I gave it 149, I'd get all the coordinates in the unsure waffle. And then for oppose, the same thing. And then with those coordinates, I could use geom_point to plot the coordinates of each of those different points, okay? So that's the strategy I'm gonna go with here. So let's give that a shot. And so right up here, I'm gonna make a new function that I'll call waffle, and we'll do function. And so this is the syntax for making a function. And I'll have n as the argument, and then I'll have n calls, and I'll set that at 18 by default, okay? And so then within these curly braces, we want to define the guts of what's going to happen, right? And so for now, let's say that n is 421, okay? And we will comment this out because I will forget to comment it out later, and then we'll get 3 waffles that all look the same. Anyway, right? And so we have the number of columns, we need the number of rows, and we'll need the number of extras, right? And maybe I'll do n underscore calls just to make it a little bit easier to read, n underscore rows, and n underscore extras, okay? And so again, if we load n calls as 18, I'll highlight and run that down here. My number of rows could be n divided by n calls. If I do that though, I'm gonna get a fractional number, right? Like 23.3888888, right? And so this plot has actually 24 rows, right? They're not all full, but there's 24 rows. And so I think what I'll use instead of just the straight up fraction would be ceiling. And so the ceiling function will, if I do like 3 divided by 4, and then I do ceiling 3 divided by 4, 4, that should give me 1, right? And so it's a rounding function, but where it always rounds up, right? And so now when I run n rows, and I look at the value of n rows, I get 24, okay? This graph looks like a memento mori calendar. Interesting. I'm not sure what that is, but I know that memento mori is remember you're going to die, right? Remember death. And so I'm kind of worried to think that maybe it's like checking off each day until your death, but I'll have to look that up later. But great. And thanks, Shunya, for tuning in. All right, so we now have the number of rows, okay? And so I could imagine creating a vector of values from 1 to n rows and a vector of values from 1 to n calls and getting all those values. But then that will give me a full 18 or 24 row by 18 column grid, right? But we have these extras, right? And so the extras then, if I come back and think, right? So like we have n calls times n rows. This is 432. This is the number of total cells in that 18 by or 24 by 18 grid. But we only have 421. We don't have 432, right? And so maybe what we could do instead would be to do n calls times n rows minus 1. And that gives us 414. And then I could do like n minus that to then get 7, right? And so that corresponds down here to these 7 extras, right? And perhaps you could test this with like n as, oh, what did we have for these other values? 149. And, oh, I forgot. So that's 5 extras, right, here. And that's corresponds to those 5 extras. And then for oppose, what did I have for the count? 445, right? And we had 13 extra there, which I think corresponds to that. It certainly corresponds to what I have here for adding on those extras, okay? So now this is going to be my n extras, okay? And I will go ahead and remove these n's because we're going to update the n for each of the different categories that we're using, okay? All right, so now what we want to do is build out the grid. And so I'm going to start with the row indices, and the rows are going to go from 1 to n rows minus 1, okay? And we'll handle that extra row separate. And so we're going to, though, repeat each of these n calls times, right? And so if I look then at row indices, what I see is that I've got 1 repeated 18 times, 2 repeated 18 times, and so forth, right? And so eventually what we're going to do is we're going to have a row indices and a column indices, and then we'll turn that into a tibble that we will then return from this waffle function, okay? So let's now go ahead and add call indices. And here again, we'll do a rep on 1 to n calls, right? Oh, and that needs an underscore. And now I want to repeat this though, n rows minus 1 times, okay? Because I'm holding off on that last row just for a minute, right? And so then if I look at call indices, I get that, which is not what I thought. I think this should be times. All right, let's try that again. There we go. And so now what you see is that we've got 1 through 18 repeated many times, right? That should be getting repeated n rows minus 1 time, so 24 times, right? And then if we look at this vector, this has got 426, 7, 8, 9, 30, 1, 2. So 432 lines. Actually, I could just do length. I could do length, row indices, 432, length, call indices, 432. So those are the same length, okay? And so this is defining the main grid, right, that I'm kind of showing here in this rectangle. But now what we need to do is go ahead and add that extra row, okay? And so we can tack onto this with a C function. So the C function adds on, or makes vectors, right? Like we see this a lot with ggplot2, where we might do C, blue, green, white, right? And so this then makes a vector of those 3 values. So we're going to use 2 vector making functions, right? So we're going to use rep and C to make the vectors we want. And so then for the row indices, we're going to have n rows. We're actually going to repeat that, n rows, n extras times, right? And so if we repeat n rows, n extra times, this should get us 23 or 24 or 25 repeated 7 times, right? And so 1, 2, 3, 4, 5, 6, 7, 8, 9. You know what? This is for the oppose condition. So let's go back to the support condition, which was 421. So we'll do n equals that, okay? And so now when we do n rows and extras and indices, this, we get 7 24s, right? Which again corresponds to then these values, right? So this is row 24. Actually, you might think of this as row 1 if you're thinking about a kind of an X and Y axis. We'll deal with that probably eventually, but there's 7 values here, right? So that gets us our row indices vector. And now we want to do the same type of thing, but with our call indices, right? And so this is going to be a little bit more tricky because the values don't fall in the column, right? So there's 7, it's an odd number, right? And so they fall in between each of these values, okay? So, you know, they're not going to start at position 1. We have to figure out what that starting position is going to be. And so if we did like n calls minus n extras, this gets us 11, right? But I could imagine that we need to divide that by 2 because we're going to have space on both sides. So that's 5.5. So then if I come over here, that's like 1, 2, 3, 4, 5.5. So it's off by 1, right? And I suspect we have an off by 1 error, as they're called. So we'll go ahead and add 1. And so that will then have it start at 6.5. And so we'll say extras start. Or actually, you know what? Let's go ahead and take that. And I'm going to use another vector making function called seek. So we'll go from n calls minus n extras divided by 2 plus 1 to that plus n extras, which is, that's just really gnarly. So let's go ahead and pull this out to make something a little bit more readable. So we'll do start extras. All right. And again, this should be 6.5. It is. And then end extras which will be start extras plus n extras. And I have to load that. And this should be 13.5, which it is. So we'll go seek start extras, end extras, and we'll go by 1, right? So this function then gets us integer values going from start extras to end extras. And I see we actually have 8 values. And so, again, we have this, what's called a fence post error. And so we're doing start extras plus n extras. But when we do this, we're not counting the start position, right? So I need to subtract 1 from here. And now when we do this seek, we have those 7 values. And so that looks like that should work. And I need to close off the parenthesis here. All right. And now what we want to do is go ahead and make our tibble. So we'll do tibble, and I'll do x equals, this is going to be the col indices, y will be the row indices. And so again, this gets us our tibble. And so it has 421 rows, which is a win, right? Because that's the number of participants. All right, so we now have our function for making the waffle, we'll say coordinates. Okay. Now what we want to do is I'm going to remove this summarize function, and we want to get the x and y positions for all of the respondents in each of these 3 categories. So I'm going to do a mutate on the tibble to make a positions column. And this is going to be a column of tibbles. And so this is something that we can do with the map function. Okay? And so map allows you to iterate over different rows of a tibble or different groups of values in a tibble to apply a function. So I'll map over category. And I'm not going to pass any arguments into waffle coordinates. So what that means is that I can go ahead in here then and paste in waffle coordinates. And it is unhappy with me. Why are you unhappy with me? Caused by error in n divided by n calls. And maybe I do need to go ahead and pass in the argument. So to pass in an argument to the function, we're going to go ahead. Oh, I know what I did wrong. I passed in category rather than level, right? Because non-numeric argument to binary operator, right? I was passing in category rather than the level. The level is a numeric, category is a text. So mapping over the different level values into waffle coordinates now gets us a column with these 3 different tibbles, right? So now you can see positions has 3 rows, but each row is a tibble that corresponds to the number of rows of respondents and then 2 columns for the X and Y, all right? Hey, Karen, thanks for joining in. So, but this is what's called nested, right? The tibble is nested within a single cell. I can unnest that by doing unnest on positions. This then gets me 1,015 rows and 4 columns. So that 1,015 should sound familiar because that's the total number of respondents to the Washington Post survey. And then we have 4 columns, category, level, X, and Y. Okay? Cool. Hey, Rents, thanks for joining in. And so again, for people that might be joining in, we are recreating this, what I'm calling waffle plot-ish type plot that was published by the Washington Post back in June, showing the responses of about 1,015 survey respondents to the question, do you support or oppose Trump sending the National Guard and Marines to respond to the LA protests? And so I have just made a function that will create the positions for each of the 3 different categories. when I give that function the number of respondents that said they support or unsure or oppose, and I gave a default column number. And so what we're going to do is we're going to then plot these points with geom_point, but we're going to make the 3 separate categories using facet wrap. And so that's basically what we're ready to do now, is to go ahead into ggplot2. So we'll do ggplot AES. On the x-axis, we'll do x. On the y, we'll do y. And then we'll go ahead and do color equals category. And then we'll do plus geom_point. And let's see what that looks like. I think it's going to be kind of gnarly, but we'll check that out. And let me go ahead and open up that file. Oh, I thought I had this open already. There we go. So this is what we got, right? Let me maybe shrink it down as I do to be the same size as our Washington Post version. And there we go. And so what you can see is a couple things, right? That we have the X and Y coordinates, but they're plotting the data on top of each other, right? That it probably put unsure down first, and then support, and then oppose on top, which is why we're seeing those red points on top of everything else. And so we'll pull these 3 apart with the facet wrap. But what I'm heartened to see is that I can see these extra values, right? Those extra responses are nicely situated between the integer values, right? Because there's an odd number of extras. So there's 1, 2, 3, 4, 5 for unsure, which corresponds to those 5. There's 1, 2, 3, 4, 5, 6, 7 for support, and I think 13 for oppose, okay? So again, now what we want to do is pull those apart into 3 different panels. And we can do that with facet wrap. And we'll do that with a tilde and then category. And we'll do nrow equals 1. And so this will keep everything on 1 row. And voila, we now have something that looks a bit more like what we have up here in the Washington Post version, right? Cool, huh? So this is the basics of the plot, right? This works, right? We would probably want to go ahead and get rid of the X and Y coordinate values. We don't need the legend off to the right because the categories are labeled for each of the 3 facets. So now what I want to do is go about taking this waffle plot and making it look more like the Washington Post version, right? And so I think the first thing I will start with is the order. Well, let's start with, let's get rid of the legend and let's get rid of the legend because that's a good place to step in. So there's a couple ways to do this. And the easiest, I think, is within geom_point to do show.legend equals false. And so that gets rid of the legend on the right side. Yeah. Maybe what we could also do as a kind of a quick win would be to get rid of the X and Y coordinates because those don't have any meaning in the plot. So we'll do that with theme. And we'll do axis.title equals element blank. We could also do this with the labs function. We'll use the labs function later for the title, but this is easy enough to do it here. Axis.text equals element blank. This will get rid of the numbers on our axes. And then we could also do axis.ticks equals element blank. And so that gets rid of the labels, right, on the X and Y axes. Let's go ahead and get rid of those grid lines, which we could do with panel.grid equals element blank, which gets rid of those. And now let's go ahead and remove the background color. Well, I'm going to leave the background color for a minute. So let's pause here, right? And something I am noticing in our plot is that there's a fair amount of extra space at the bottom and the top of, well, our oppose category, right? Really, all three of them have an extra bit of padding on the bottom. And oppose has the most rows, and so it's kind of the reference point, and it has extra space at the top. And so if you've been watching these videos for long, you know how I solve that problem. So think for yourself for a second how you might go about doing that. And I will tell you that I will do that with chord Cartesian. Okay? And so chord Cartesian will allow us to, as this pop-up shows, change the limits on the x and y axes. There's an expand equals true, and there's a clip equals on, right? And so what I'm going to change immediately is the expand equals true. The expand equals true adds a certain amount of padding all the way around the plot. The clip equals true, or clip equals off, means that if something's outside of the plotting window, then we want to have it be clipped, right? So let's start with expand equals false. And so now you can see that we have no border around our data, right? That doesn't look so great, right? But if we came in here then, again, clip by default is off. So if I do on, then what I expect to see is the rest of each of those circles that's on the border, okay? And that actually didn't work the way I thought it would work, which is surprising. Oh, I did on. I want off. All right, there we go. Now that works right? And so that works, right? And we could perhaps, there's ways to make this look better by futzing with kind of the position between the three facets. I think what's going to be better, though, is to change the limits on each of the three facets. And the three facets will have the same limits, right? And so in here, we can go ahead and do xlim. And again, it goes from 1 to 18. So let's go from, say, 0.5 to 18.5. That should give a half a unit margin on the left and right. Cool, right? And so now you can see that it brings that in. And so we want to do the same type of thing on the bottom and top. And so now let's do ylim from 0.5 to, say, 25.5. Okay, and then that brings that in. And because some of you might be saying, well, 25.5, that's like, do new. I'll leave that. Like, there are ways that you could not hard code this, but I'm gonna leave it hard coded. So, but again, you could play with that, right? So now we have a nice, tight representation of the data. I'm now going to go ahead and turn off that background. So we could then do panel.background equals element blank. And then to get rid of the gray background in those titles, we could also then do strip.background equals element blank. And there we go, right? So, looking good, right? And so Rents suggests another easy fix, add a capital to each category, right? So, I hear you. And so, because you mentioned that, what we could do, like he says, is support, unsure, oppose. And we get it capitalized, right? And, but they have these percentages underneath each of the three, right? So I am going to build a more advanced title, okay? And so because you brought this up, I'm going to work on this now rather than working on the colors, okay? So let's go ahead and work on our strip titles. And so what I think will be easiest in the long run is to put these back to being lowercase. And then I'm going to make a new column that I'm going to call label. And you know what? I think what we will do is I'm going to split this apart. Okay. And so I'm going to call this, am I going to strip it apart? No, let's leave it together for now. Okay. All right. So we'll go ahead and do label. We'll do facet label, right? And to do this, we're going to have several things going on. So we've got the title, we have the percent. The percent is on a second line, which we can kind of manufacture the string by putting in a line break of some type. But what's interesting about this is that the title is bolded, whereas the percentage is lowercase, right? And so I think what we'll do is to go ahead and use element markdown for the strip text. And what that will allow us to do then is to use HTML and markdown to style these different labels. And so before I forget, let's come down here and we'll do strip.text equals element markdown. And because we're using element markdown, we also need library ggtext. I love ggtext. It's a great package for doing stuff with text, right? And so running this, it's upset because I didn't finish this. So let's go ahead and, all right. So nothing changes, right? And so another tool that we will use to make out our string is a package called glue. And so glue is, I find, an easier to use version of paste or paste 0. And so we're going to use glue to make our facet labels, right? So we can then do glue as a function, and then we create a string. And so I'm going to start by putting in the 2 stars to make something bolded in Markdown. And then I'm going to put in curly braces a variable, which will be category, right? And so what this does is that this will take the category column and it will insert it into a string that is bounded by those stars, okay? And yes, Mike is asking, do you need to do it in a mutate in order to do the percent calculation? Yes. So I was thinking that I would just kind of do it like bam, 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 but this wouldn't be dry. I'd be repeating my code a lot, right? So great point. I'm going to go ahead and remove this, and I'm going to cut this and add it to a mutate. I'm going to make a separate mutate because I have a feeling I'm going to be pulling things apart. I'll go ahead and clean this up later, but we'll do label equals glue category. And so if I run these first few lines here, you'll see that my label now has support, unsure, oppose. And so now when I run this with the element markdown, those 3 labels should be bolded. They should be bolded. Why aren't you bolded? Oh, I know why they're not bolded. Because I'm not using label anywhere, right? And so I think what I need to do is facet wrap on my label. And so now I'm using my label, which is the bolded version of the category, okay? And so now what we want to do is go ahead and capitalize those, right? And so I could, like Rent suggested, capitalize these letters, but that wouldn't be dry, right? So within string R, string R. So the string R package is built on string I. There is a function called str sentence. Let me see. str 2 sentence? Yes, str 2 sentence, which if I move my fat head here, there we go. You'll see that str to sentence converts to sentence case, where only the first letter of the sentence is capitalized. We could do also str to title, but anyway. str to upper and str to lower are a lot like the base R to upper and to lower functions, okay? So let's go ahead then, and we will use that here. We'll do str to sentence on category. And so now what we get when we run this is the first letter of each of those three titles capitalized. Winning, right? Awesome. All right. So now what we want to think about are those percentages, right? And so we can do that with another mutate. And so I think I'm going to put that with this label mutate, where we'll do percent equals, and we're going to take level divided by the sum of level. Okay. And we're going to need to multiply that by 100 because we're looking at the percent, not just the fraction, right? So if we run these lines, we see that we've got 41.5, 14.7, and 43.8. So we need to round that, right? And so we can then do round that, and we can do n digits equals 0. And again, if we run these lines, let's see that those decimal places go away, and it's not happy. Oh, what are the arguments for round? Let's see. Round digits equals 0. Oh, I did n digits. All right. So we want digits equals 0. And oh, I got ahead of myself because I haven't added that to the plot yet. So let's go ahead and look at everything with that mutate statement. And now we have that 41, 15, and 44. Okay, cool. Now we're ready to add that to our label. And so because we're using Markdown, we're going to use HTML. I can't use \n, which is what I would normally use as an ASCII character. So we'll use BR for an HTML tag for doing a line break. And then we'll do percent. Actually, that needs to be in curly braces. And then a percent sign. Right? And so now when we run this, we get our title with our percent values under that, right? Very cool. This is the sans serif font part of the figure. So let's go ahead and in strip text, we can do family equals Franklin. And then this gets us a font that looks very much like what they used in the Washington Post. Let's also separate those lines a little bit. They seem pretty tight. So I'm going to go ahead and do line height equals 1.3. And that gets us pretty decent separation. We might fiddle with that later, but there we go. There are our titles, right? So let's take a pause here so I can get a drink. So again, what we've done is we've made the individual waffle coordinates. We've represented that with geom_point. We've then used facet wrap to pull those apart to make the three different categories. And then we've removed the axis text and ticks and titles. And we've also removed the background and those grid lines because they're not relevant for what we're doing. And then we've gone ahead and formatted these titles. I think the next thing I want to do is to change the order of these three different categories to match what they have going support, unsure, oppose. If you're new to this, the default order is alphabetical, right? So oppose, support, unsure is the alphabetical ordering of these data. So let's go ahead and change that order. And so whenever I want to change the order of something, it's usually going to be a factor. And so let's go ahead and we can do that in here. So we'll take category, and I'm going to make that a factor on category. And the levels, again, by default is alphabetical, but I'm going to use the levels that are seen in the category column, right? And so I hate that. Whenever I run something and then I expect it to work, let's see. Let me try opening it again. Nope. Why didn't you work? Let's try running it again. Nope, that didn't change anything. So that didn't work the way I thought it was going to work, right? So let's go back and run this and see what we get. So category is a factor, support, unsure, oppose. Oh, right. And that is most likely because I'm faceting on label, not on category. So let's go ahead and we'll move this factor statement down below after label. And I'm going to change category to label in this statement. Now we get support, unsure, oppose, right? And so again, what I screwed up on was that I was making category, which was support, unsure, oppose, into a factor, but then faceting on the label, okay? And so this is better. All right, so an important thing to do to make it look immediately a lot more like the Washington Post version is we need to flip the axes, right? And so again, there's a variety of ways you could do this. One way that I often do that's a bit of a hack would be to multiply all of my y coordinates by -1, right? And that way then I would go from -1 down to -25, and that would immediately get the right ordering, right? It's a bit of a hack. It works for sure. We could also do a better job of designing our function, right? That's probably the best thing to do, right? Like here where we have row indices, I could flip that. And then a third approach that I actually want to try because I've been thinking about this stuff lately is to transform the y-axis, right? So we could do scale y continuous, and then we could do transform equals reverse, okay? So let's try that. And so that didn't change anything. I'm gonna try to remove these limits for a second and see what happens. There we go. Yeah. So I kind of critiqued the negative sign as being a little bit of a hack. And what I'm doing here is also a bit of a hack because now I have to change this to be 18.5 to 0.5 and 25.5 to 0.5. Because the axes have been flipped, I also then need to flip my limits, right? So an alternative to this probably would have been to come back here and alter my row indices, right? And that would be, let's try that. So I'm going to comment this out. So this would go from n rows minus 1 to 1. Actually, no, it's going to go n rows to 2, and then row 1. No, that's not what it's going to be. This is going to be harder because it's going to be 1 in oppose, but it's going to be something different for assure and support. All right, I've talked myself out of it. I'm going to undo all these modifications real quick and then leave in my transform reverse and my chord Cartesian, expand clip, xlim, ylim. All right. So hopefully that you can see kind of what we're doing here with this transform equals reverse, that flips the order. Other transformations that you might be more familiar with would be things like a log transformation, right? We could make the y-axis or the x-axis logged, right? Oh, is there scale y reverse? Probably there is. Let's try that. So we can do scale y reverse. Yeah, it's the same kind of idea. And in my recollection, there are more transform argument values than there are scale y whatever transformation values. So thank you for that suggestion. So both Mike and Syed got that like instantaneously with each other. So thank you for that feedback. I'll leave that in here. Great. All right. So let's again remind ourselves where we are. We've got things in the right order. Let's go ahead and try to match those colors because that always does a lot to make the plot look more like the original. So to do that, I'm going to open up my digital color meter, which I have in utilities. Again, in a Mac, we've got this function, digital color meter. If you're on a Windows computer, it's the same idea, right? And so we are using category for color, right? And so what we can do is I'm going to come in here after facet wrap and we'll do scale color manual and we'll do breaks and we'll do support unsure and oppose, and then we'll do values to get the three colors for those three categories, and then we'll add that in. Okay. Hey Rodrigo, thanks for joining us from Brazil. It's great to see such an international contingent here. All right, so we'll come back to theirs with our digital color meter, and I will grab this tealish blob, copy that, plop that in there. That's pretty much the same color. And then the unsure, we'll grab that and then plop that in. And then I notice oppose, I forgot a comma before oppose. All right, and so then we'll get this orangish color and we'll plop that in and run it and compare. And now we see that we have the same colors that they have in theirs. So winning, right? Awesome. We're making a lot of good progress here, okay? All right, so the next thing that we need to take on is that title, right? And so I'm going to see if I can copy and paste this, because if I type it manually, it's going to be painful for everyone to watch all my typos. So we'll do labs, and I'll do title equals that. And we'll leave that for now. So let's go ahead and add a plus to the end of this. And so now we see that we have our long title. Doesn't look like theirs, and it goes off the right side of the screen. What we will use is another function. So the title can be changed within theme using plot.title. But plot.title takes an element text argument, which doesn't give a border, right? And there's no border, there's no background, if you will, for the title. And so to get that, we're going to use a function from ggtext called element text box simple. So we'll do plot.title equals element text box simple. So let's start there. And also for a quick win, let's go ahead and do family equals Playfair. That was our serif font. There we go. Nicely, it automatically wraps the title for us and goes ahead and puts in that Playfair font, right? Cool. I want that to be bolded. So in here, we could also do face equals bold. It has a lot of the same arguments. Actually, I would say I think all the element text arguments are also in element text box simple. Element text box simple has some extra arguments, as well as this nice feature of kind of wrapping the text. And so now we see that that is bolded. Let's go ahead and see if we can't make, let's make the border, okay? And so to remind myself, because I don't use this a lot, element text box simple, let's look at the help. And we will then see, element text box simple. Element text box simple has a lot of good defaults, right? Whereas element text box, you really have to specify everything. And so if you look at the arguments for element text box, everything is null, which means basically you have to set all those values, right? Whereas element text box simple has a lot of that stuff for you, okay? So the first thing we want to do is line type, and that will get us a solid line. So we'll do line type equals 1. And there we go. We now have our border around the plot, right? And we could add some stuff to this. So we could say like align width equals 0.25. And that then makes a thinner line. We could do padding. I'll get it eventually. Padding takes a margin argument. And so that's going to be the padding around the text, but within the border, right? And so again, it's TRBL. So top right, bottom left, treble. And so let's do, say, 5 all the way around. And so that gets us a border, which we can kind of futz with that padding value as we go along. Let's go ahead and change the radius of kind of the circular corners. So we could do R equals something, and the R takes a unit argument. And so we'll say 5 PT, so 5 points. And we can see that gets us nice rounded corners, right? Cool. So the one thing we can't do with element text box simple is make this lower left corner square like they have in the Washington Post version, right? I'm willing to live with that, right? Thanks, Mike, for that help about using F1 to go straight to help. That's good. And Nick, thanks for joining in. You're joining us from Greece. That's awesome. All right. So let's go ahead and so we basically have everything now in the plot except for the logo. I'm going to add the logo last. So let's go ahead and make everything else look like the Washington Post version. And I'm going to, basically what we need to do is modify the title to make it look more like theirs, okay? So let's go ahead and increase the font size first. And what I like to do is increase the font size to basically match the wrapping that they have in the original, okay? So we'll increase that size by doing size, say, equals 20. And so this gets us the same number of lines, but things aren't on the same line, right? And maybe the other thing I notice is that their title doesn't go all the way across. Like mine goes all the way across, right? So in here, we could go ahead and do like width equals 0.9. And so then that screws some stuff up. That makes the width of the text box 90% of the overall window, but it's centering the text box, if that makes sense, right? So we could also add in here hjust equals 0. And so that pulls everything to the left, right? And so then, what do we see? We see that kind of this ends at about the same spot relative to oppose as theirs does. But because I shrunk that text box, we now need to shrink our font a little bit because we now have 4 lines rather than 3, right? So let's come back up here and we'll do 18. All right. Maybe up it to 19. I did 20 and that wasn't good. So maybe what I'll do is let's go to 19 and we can add some padding to better match their padding, right? And we can probably increase the line height as well. So let's increase the padding to start. And let's maybe increase this to 8 all the way across. That's pretty decent. And oh, what? Just kind of want to match the left and right. I think the left and right maybe have more padding than I'm giving it credit for, so I'll maybe do 12 on the left and right. All right. And so that actually matches their wrapping, okay? We'll roll with that. And so let's also increase the radius. Let's go up to, say, 10. We could probably go higher. Let's go up to, say, 15. And I think that is a pretty good match of the curvature of their corners. I think that looks good. All right. There's also a bit of a margin below the title, right? To separate it from like the titles of the 3 different categories. So now maybe we'll do this under padding. We'll do margin equals margin. And I'm going to do 0, 0, and then like 15 and 0. So again, padding is within the border and margin is outside of the border. So that gets us pretty good match. It could probably be a little bit better. The line height could also be a little bit higher. So again, many of these things are things that you probably wouldn't worry about if it was your plot. But if you're trying to recreate something else and you want to know like how they did it or how you would make it kind of a perfect representation, that's what I'm trying to do here. So that increased the line height. And I think that's pretty good. We can get a little bit more margin at the bottom to match theirs. Let's go to 20. And bang, that gets that to just kind of pop into shape. Cool. And nice. So now what we need to do is we need to get in this logo in the left side, right? So to do that, I'm going to go ahead and work on the margin all the way around the plot, okay? And so that's going to be another theme element. So we'll do plot.margin equals margin. And at the top, let's do, say, 5. The right, I'm going to do 10. The bottom looks really good as is, but I don't know what the default value is. I'll say B equals 5. And then L, it's going to be pulled in quite a bit. So let's go L equals, let's try 20. And that screwed up our title. We'll deal with that later. So I think on the left side, sorry, on the right side, that margin looks pretty good. On the bottom, that margin looks pretty good. The margin on the left, I think that also looks pretty good. Okay, so we need to fix the top margin on our plot. And let's see, so the top is 5. Maybe I need to add a bit of margin to the top of my title, so I'll put in 1. That didn't do much. It brought down just a smidge. Let's make that maybe 5. Brings it down more. So I also screwed up the line wrap with all that. I mean, I didn't screw it up, but whatever. Let's go ahead and reduce the margin a smidge. Let's go to 11 and 11 on the left and right. Maybe 10 and 10. I'm thinking that if I get the word wrapping correct on the plot, on the title, then that might bring down that bubble a little bit. So let's go to 9 and 9. All right. Maybe I'll increase the width. 9.2. Oh, let's do 9.4. Okay, I'm going to make these 8 and 8. Okay, that didn't exactly do what I wanted. Maybe I'll make the left 8 and the right 9. Or 10. All right, this is the last thing I'll try. Whatever. I will leave it there. I know you don't want to watch me futz with all this, because it's pretty mind-numbing to watch. So we'll roll with that. I think I'll also then go ahead and remove that margin here, this 5. I had it as 0 before. Oh, maybe that should be 3. All right, cool. All right. At last. And maybe because I can't help myself, let me see what happens if I make this back to 9.2. All right. There we go. There we go. That's it. I got it. I won't touch anything. All right. Sorry about that. Shouldn't the space between the facets be a little bit bigger? Sure. Yes. Good call. Let's try that. Thanks, Renz, for that question. So to do that, I'm going to put that with the strip. So let's do facet dot or panel dot spacing dot x, and that takes a unit. And so this is the spacing between facet panels. And so we'll do unit, and let's do like 10 pt. Bang. I think that's pretty good. Yeah, I think that matches pretty well. Hold on to that thought about from Mike about the irregular rather than perfect circles. I don't know that I will do that, but we'll see. I will tell you how I think I would do it. So now let's go ahead and bring in this Washington Post logo. Okay. So in where did I put you? Right there. I have a screenshot of the Washington Post logo here, right? If I zoom in, you can see it. I basically made a square around this Washington Post logo here and then saved it as wplogo.png. So I think the last time I put a logo in, probably from the Our World in Data fertility infographic, we used ggplot to do it, and that was the first time I had done it, and it was a bit of a dumpster fire. I mean, we got it to work, but it was scary. So I'm going to use ggimage this time around. And so ggimage brings in a new geom called geom image. Okay, and geom image allows us then to add a image, right? And so what we could do is geom image, and as an extra aesthetic, I could then do image equals, and then I'll do wp logo.png. And I need to give this, well, let's see what happens when we do this. There we go. It ain't pretty, right? And so what I have found is that this is actually turning my symbol, my logo, into those colors, right? And so if what I'm going to do is go ahead and move this color equals category aesthetic into geom point. So we'll do AES, color category. And so now what we get are each of our plotting symbols replaced with the Washington Post logo, right? And so to Mike's question about the, to his question about like the non-perfect circles, I would probably do something like what I've accidentally done here, where I would actually make an extra column where, I don't know, one approach would be to, I haven't looked at this closely enough to know if they're repeating certain shapes over and over again, but this is kind of the idea that I would do, right? But of course, and I have another idea that maybe we'll come back to, but for right now, one thing, it's obvious this is wrong, right? I want the Washington Post logo up here once. I don't want it replicated over and over again, right? And so let's go ahead and not do that. And so to change that, I'm going to put in a x and y value. So we'll do x equals, let's start with 1, and then y equals, again, remember we've got 1 at the top and like 25 at the bottom. So let's do y equals 0. All right, and so it is saying all aesthetics have length 1, but the data has 1015 rows. Please consider using annotate or provide this layer with data containing a single row. Okay. And so let's come back to that. And so Renzo says, thank you very much. Please, your videos could have more viewers with YouTube auto dubber option. Thank you for that suggestion. As I've said, I'm still kind of learning how to do this, and I will definitely look into how I can add that on my side so that's easier for you to do. Hopefully when people are watching this later, they can see the subtitles that are automatically generated as we go along. But I'll certainly look into that for future episodes. So thank you for bringing that up. I definitely want to have as broad a reach as possible. Okay, so this is putting the logo on all 3 spots, and it's putting it in the right-hand column, which is weird. And I'm getting this warning message that basically my x is 1, y is 0. So that's 0. That's weird. So I think what I will do is break this apart now. Okay. I think I'm going to make a data table for the image, and I will then make a data table for the data, right? And so I'm going to break it apart here, right? And so this I will call data. And then here we'll have data coming in here. And I'm going to modify this data. Oh, I forgot the wrong symbol. What I want to add then is a column for the logo, right? And so here I'll put under support WP logo.png. So the nice thing about RStudio is what I can do is I'm in this directory that has this PNG file. Within quotes, I can type WP, or really nothing. I can hit tab, and it opens up this window with all of the files in that directory. So I can click WP logo.png. And then down here, I can put quotes, empty quotes, to indicate like there's nothing there, right? And so this logo will be the aesthetic. And so now down here for geom image, I'm going to say data equals data, and then x, y, and that image. Or maybe I'll do image equals image, right? Or logo, right? And so the other thing that this is going to do is that instead of having the Washington Post logo show up in all 3 plots, it should only show up in 1 plot. So let's see how this works. It doesn't work because I forgot a comma at the end of logo. So we'll try that again. All right. Caused by image read. Must be a URL, file name, or raw vector. Uh-oh. So Nick, the poll had 1,015 participants, and then yeah, so 18 million people, right? So 1,000 is commonly used in a lot of polling. If you look at like political polling, where you'll see things like plus or minus 2.5%. And so, you know, we don't need to do all 18 million people. And I forget if this particular set of data is only people in LA or if it's people all across the US. Jarman says, could you use, so this is getting back to the question about the non-perfect circles. Could you do multiple points per XY and then give them a slight jitter? That's exactly my thought, right? And I think that's, Rentz is saying if you look at the original, they seem to have different shapes and rotation of the circles. So my thought would be to do what Renzo does. So we'll come back to that. But of course, I'm struggling right now with this image equals logo. And it's saying error in image read. So I'm going to go to the help. So I'll try this F1. And at least on my Mac, it's not working. So I'll do geom image. And so let's look through here. And I want to see if there are examples that I can use. And so let me pull this over. So they've got image with these URLs. This is a data frame. And then ggplot plus geom image AS image equals image. Don't know what I'm doing differently. Again, if my data, oh, nope, I've got logo right there. Maybe it doesn't like these quotes. So for now, I'm going to put in the WP logo for all three. And let's see if that gives me the same error. No, it doesn't give me an error. Cool. Oh, but I have to save it. And for some reason, it's putting it off on the right, which is weird. Oh, I know why. So I accidentally flipped the x-axis and the y-axis, right? So the limits on the x-axis go from 18.5 on the left to 0.5 on the right. I didn't want to do that. I only wanted to do that for the y-axis. So let's do 0.5 to 18.5. And I forgot a 0.5 here. Okay, that's better. Cool. All right. Now let's go ahead and see if we can't turn this WP logo for unsure. Let's try NA on that to say that I don't want a logo for those. So it's warning me that it removed 2 rows containing missing data. And so maybe what I will do is to come down in here, and in my geom image, I'll do data filter, or maybe I don't need the pipe. We'll do filter data category equals support. Okay. So basically what this is going to do is give me a 1-row data frame, right? Bingo, right? Now we have the Washington Post in the upper left for support, and not on these other 2 categories, right? Okay, so now what we need to do is move this up, left, and make it bigger, right? And so again, I talked to you about the clip equals off in chord Cartesian, right? That's what allows us to plot stuff outside of the plotting window, right? Like this logo right now is outside of the plotting limits, right? Because we gave it, what? I gave it x of 1 and y of 0. I don't have, my y limit is 0.5, right? As the starting point, right? So let's do x equals -1 and y equals -3. And there you go. We now see that it's in the left-hand margin, but why is it down there? If I do 3, that moves it up. I think weird things are happening with that reverse. I'm going to roll with it and just keep moving that up. Maybe we'll go to 6. That keeps going up. And let's try 8. And that's pretty close. I'm going to bring it down to, say, 7. Okay. And let's then go ahead and make it bigger. And so we can make that image larger than by doing size equals, say, 1. Okay, that's huge. Let's do, say, size 0.2. Okay, still a little too big. And let's go to, say, 0.1. And maybe I'll make it 0.12. And I'll move it up ever so slightly to, say, 7.2. And I think that's, maybe I'll go up just because I can't help myself. You know me. You all know me well enough to know that I can't, I have to have things look just right. I'll do 7.5. There we go. Cool. Right? So it's like the same size. Awesome, right? So, because I've already removed my, I don't know that there's a rotate, right? So that might be hard. I liked the idea that I think it was Darman56 suggested, which would be to perhaps add more data and to jitter those points ever so slightly, right? And so let's try that, right? And let's think how we would do that. I think I will replicate call indices. Let's try 3 times. And then y rep row indices also 3 times. Oh. So this should give us the same value. Oh, it's unhappy. Let's see. What does this do? So column Y only has 421 rows. Oh, because I put the parenthesis in the wrong place. All right. Okay. So it should give me the same result, right? That gives us the same plot. And cool. So now the suggestion would be to use maybe geom jitter rather than geom point. So let's try that. Let's try geom jitter. And that's not exactly what we want, but I think we're gaining on it. We could come in here and we could do position equals position jitter. And there's a width and height. So let's do width equals 0.1, height equals 0.1. Oh my gosh. That's awesome. I mean, it's obviously not exactly what they had, but that's pretty awesome. That looks, those look a lot like theirs, right? And I'm sure you could fiddle with, you know, whether you use 3 or 4. Maybe you would want to shrink the point size a little bit, but I'm going to leave that there. I think that's great. I think that's really awesome. And let me go ahead and put these side by side so you can see the difference or similarities. Theirs is, again, on the left. You can tell theirs because they have a right angle in that bottom left corner. Oh, I'm going to... whatever. That's good enough. So, again, theirs has the right angle in the bottom left corner. You know, how would I do that? I think if I wanted to do this, I would either figure out how to hack at element text box simple to control the radius on each corner separately, or I would, I don't know, figure out how to draw a half circle there over top of this and then draw in a right angle. Whatever. I don't think it's that big of a deal. But on the whole, I think this works out great. I wasn't planning on doing the jitter bit today, but I think that looks pretty cool. Mike says you can set a seed in position equals jitter, so you get the same thing over and over, right? So if I rerun this, you'll notice that as I kind of toggle back and forth, the plot changes a little bit, right? And so if you want it to be set, then there's a couple things you could do. In geom jitter, and here I think we could do seed equals 1976-06-20. That's my birthday. And so that, if I run this, pegs it, right? It doesn't change time after time, okay? And so then Chris says, do you know what they made theirs in? I don't know. I don't know. I think this was made by Philip, or no, it was made by Shuka Subarim, right? Who was the original author of the article. So anyway, so Darwin also suggests might also play with alpha. And so the alpha changes the transparency of the individual points. So let's see what happens if we do that. I don't think that's going to give us the effect we want, but let's try. So we can do alpha. Okay. Let's say 0.5. That gives it a more muted color, and you can, if you kind of look closely at those circles, you can begin to see that they're circles that are kind of superimposed, right? So I think I would stick with the default alpha and not worry about that. Okay. Any other questions that people have? I think this turned out great, a lot better than I thought it would. And for a plot that's relatively simple, one might say, I think there are a lot of really cool elements in here that we were able to discuss. Again, writing our own function to create the X and Y positions for each of the participants in the survey, representing that as a geom point and then a geom jitter plot to get the kind of non-perfect looking circles, and then faceting it, right? And that we were then able to go ahead and to do what? We set the order of the title of our facets to go from support, unsure, oppose, rather than oppose, support, unsure, right? We also made those special titles where the header was bolded, and we then put the percentage in, and we did that using both glue and element markdown. We also then made that fancy title with the rounded cornered border using element text box simple, where we changed a number of parameters, but we could get the curvature on those corners using the R argument, and we could change the thickness of the line using line width. And we also then brought in the Playfair font, which is a serifed font for the title, and the Franklin font as a sans serif font for the titles of our facets. And then we saw how we could use geom image to bring in this logo, right? One thing I'll also add about that is that using facets makes things a bit more challenging when you only want to modify one facet, right? So it's a bit of a hack that I added this Washington Post to support because I'm modifying this facet, right? And so we saw that where we had like Washington Post show up in all three facets. And so ultimately what I did there was, again, used Washington Post, and then I I used filter, right, to then just plot the data for the support category, right? And so that's a bit of a hack. One other thing that you might think about with geom image is that you could use geom image like geom point, right, where you would plot a image at each XY coordinate point. And that would be another way to get kind of these non-perfect circles. But hey, I really like this geom jitter strategy, and I think that worked really well. Okay. Let me see. Got a few other comments here. Let's see. The alignment related to the title text of the logo in your plot is different from the original. Is it? Yeah, maybe it could be adjusted ever so slightly, but I'm going to be cool with that. And yeah, so Chris, I'm glad you're able to join us. And thanks everyone for tuning in. As always, feel free to leave comments below as you watch this in the future. Feel free to shoot me an email at pat@rifamonas.org. If you have ideas for other plots you would like to see me work on in the future, I would be very happy to do that. Also, be sure that you subscribe to the newsletter where you can get kind of a 3-week or 2-week and anticipatory coverage of these plots where I, again, give that like 30,000 foot view of how I would go about recreating this visual. Okay. Well, I am trying to post these every Wednesday morning at 9. I skip some every now and then as I did last week, but I again really appreciate you all for tuning in and the great conversation that we were having in the chat today, and your all's questions and comments and suggestions as we went along really made this just a lot of fun. And I will be posting the code that I generated at a link that will be down below in the description here after I finish signing off with you all today. All right. Well, thanks everyone, and really appreciate you for tuning in. Please tell your friends about what we're doing here in Code Club, and I will see you next time for our next live stream. Take care and be good.